Yes.
Light, camera, fractions.
Okay, cool. All right.
Little late on that one.
So up to this point, you know how to do one style of graphing, which is using a T-chart. And that T-chart method works for everything. You can use for any kind of an equation, no matter what shape, you can use a T-chart. All right? And so it's good to know that as a foundation, to have that as a foundation. But most of the time, you're not going to use that method. You're going to use the quick and easy shortcut method. You know, I mean, I'm sure most of you, it probably took a little time to do the homework last night, right? I mean, it probably took, like, I don't know, for some maybe at least 10 minutes, at least, maybe 15. But so I would say several people probably were over half an hour doing it, because there's a lot of computation, right? You have to compute 3 different things for each of the problems. In this, using the shortcut method, you will be able to graph these in under 5 seconds. I mean, literally, that's how fast. So when I give you a homework sheet tonight with 12 problems in it, let's see, it might take you 2 minutes. The key is that you know how to do it, right? That's the key, right? So we are going to use, there are 3 useful ways of writing straight line equations. This is the first one, the slope-intercept form. You're going to hear me say this a lot. 3 useful ways of writing straight line equations. All right? This is the first one, slope-intercept. All right? It's really important that you memorize that name, the slope-intercept form, and that you recognize it as this, y equals mx plus b. This is the form. In a real life equation, the m would actually be a number, and the b would be a number. You would still have the y and the x, but the m would be a number and the b would be a number. So you need to understand, first of all, what is the m and what is the b? And it's exactly what it says in the title. That's why you want to memorize the title. It says slope. Well, your m is your slope. Now, why mathematicians chose m for slope instead of s? Maybe, I guess s looks too much like a 5, right? Yep. So that would be kind of a bummer. But, so m, mountain, so we could think of a mountain slope, right? When you're skiing down or snowboarding down, it's a mountain slope, right? So m is your mountain slope. Does that make sense? Yeah. So this is your slope. Okay? And the way you measure slope is measured as a rise over a run. It's always a fraction. When you actually describe a slope, the slope of a ski slope or the slope of whatever, a staircase or whatever, it's rise over run. And so slope is the same thing, slope, or I'll say m, which means slope. Slope is rise over run. Okay? So when you think about it, if I said the slope was 1/2 on a graph, think about it, I would, let's say I started at 0, 0, I'd rise 1, hang on. If I started at 0, I would rise 1 because it says the slope is 1/2. That means I rise 1 and I run 2. So I'd rise 1 and I'd run 2 and I put a dot. Then I'd rise 1 again and I'd run 2 and I'd put a dot. Okay? And I could draw a straight line. Right? Now, let me show you. Okay, so that's what slope is. Does that make sense? Slope is measured on rise versus run. Rise over run. Okay. Second thing is this. What do you think that is?
Intercept.
Yeah. Which intercept, though? There's 2 of them. We've got an x-intercept. We've got a y-intercept, right? Which one? Y. Why? Yeah, that's right. Sounds like I'm asking. So that is your y-intercept. In other words, what is the y-intercept? Can somebody tell me what the y-intercept is? Or a definition, Silas.
It's where the line crosses over the line.
Yeah, perfect. So we automatically know a point when something is written in slope-intercept form, we automatically, right away, know one point on the graph. That point is on the y-axis. So if I said y is equal to 2x plus 4, I could go, let's just do it right now. Y is equal to 2x plus 4. All right, here's my graph. So draw your graph. Get some lines in there. I know immediately that my first point is at 4 on the y-axis. So I go up 1, 2, 3, 4, and I put a dot. I know my graph, the line will pass through there. Does that make sense? Right? As long as it's y equals mx plus b. Some people call this the y equals form because it's so important that it just says y equals. It can't say 2y equals, 4y equals, 3y equals. It's got to be y equals. Okay? And then, so if that's my first point, I know that my line from any point on the line is going to have the slope of whatever the slope is, right? It's going to all have that same slope. What's my slope? 2. But that's not a fraction. I have to have it in a fraction because the slope is a fraction. This is the finally we want a fraction, right? For years you guys have been dreading fractions. Oh, let's get rid of the fractions. Now we want a fraction. We want slope to be a fraction. Unfortunately, it's not a fraction. So Gavin?
Could you possibly turn it,
No, you're right. Say it. You're right. Make it a fraction. How do you make it a fraction?
Make it 2 over 1.
Is that what you're going to say?
Yeah, make it 2 over 1.
Yes, exactly. I knew that's what you were going to say. So now it's a fraction. So now I have a rise, and now I have a run. Does that make sense? Okay, so, but from where? Like, can I just start anywhere and do rise, run? No. Maybe start here, start here. No. Yeah, I got to start at the 4, right? That's a point that I know is on the line. So I'm going to start at 4, and I'm going to rise to, remember the upstairs one is rise, the downstairs one is run. So I'm going to rise 2, 1, 2, and I'm going to run 1, and I'm going to put a dot. And just for the fun of it, I'm going to rise 2 more and put another dot. Rise 2 more, right? And then run 1 and put another dot. And look at that, I have 3 points in a straight line, and I can draw my line, and I have now graphed that graph. Isn't that cool? It's so much easier, right? So much easier. Oh my God. Okay, so let's try a few. All right, let's try this one. Let's try. All right, so let's try y is equal to 1/2 x minus 7. Okay, so like using a t-chart, that would take a little computing, right? It's like, I mean, it wouldn't be that hard, but it would take a little time. So immediately though, I know I got to go down to where?
7.
Not 7.
Negative 7.
-7. The sign that's in front of it's important. So it means I got to go down 1, 2, 3, 4, 5, 6, 7, and I put a dot. Okay? I put a dot. Now, from that dot, I know that dot is part of my line. So I'm going to just start at that dot and do my rise over run, right? So my rise is what?
2. 1.
1, and my run is?
2.
Okay, so from that dot, I'm going to rise 1, and I'm going to run 2, right there, and I'm going to put a dot. And then I'm going to rise 1 again, and run 2, put a dot. And look, they're in a nice straight line. I'm going to draw my line, put an arrow on the end of each, and I'm done. That was so easy. I mean, it literally takes like 4 seconds, in all honesty, to do these, right? And Caleb really, really digs this, right? I can tell in his face. He likes that it goes fast, right? All right, let's try another one. Y is equal to 2/5 x minus 4. 2/5 x minus 4, what do I do? What's the first thing I do? I do the last, yeah, go down to -4. 1, 2, 3, 4, that's my point. Okay? And then what do I do?
Rise to.
Rise 2, run 5, boom. And since it's such a long one, I'm just going to do it, let's see, rise 2, run 5, I'm just going to do it once. And I just draw my line and I'm done. Look at that. Easy, easy peasy. Now, what is x when the y-intercept is -4? What is x when the y-intercept is -4? The y-intercept is -4. What is x? What is this point?
0.
It's 0, 4, right? -4. 0, -4, right? 0, -4. So, that's interesting. To be a y-intercept, right? Think about it. To be a y-intercept, x has to be 0. There's no way you will be on the y-axis if x is not 0. If x is 1, you're going to be over here, right? If x is -5, you're going to be over here. You see what I mean? X has to be 0 to be on the y-intercept. So you can find the y-intercept in any kind of equation by making x 0. Look at this. If x is 0, what's 2/5 times 0? So I'm going to just cover it up. Y is equal to -4. That's a way you can always find your y-intercept. The beauty of this equation and this form is it's already set up.
Wait, so
That
you don't,
is your y-intercept.
So you don't need to like do any solving to make.
Right. When it's in this format, you don't need to do. And if it's written, remember I started my lecture saying there are 3 useful ways to write straight line equations, right? This is the first one. The beauty of this one is that is your y-intercept. Because when x is 0, that disappears. And why is that? In the other forms, you actually have to solve for your y-intercept by making x 0. Make sense? See what I mean? All right. Now, what if I did this, though? All right, let's get rid of that. What if I threw a curveball at you? What if I gave you this? Y is equal to -4 thirds x plus 2. Now, when I have a negative slope, think about it. Well, some people make a mistake. A common mistake is they think, oh, well, a negative rise would go down, right? And a negative run would go to the left, right? You with me? And so a lot of people do that. But think about it. If you did a negative, let's just see, if you said -4 over -3, then you would go down and you would go left, right? But is -4 over -3 is the same as -4 thirds? No. This is +4 thirds, right? Negative divided by negative is positive. So you don't want to make both top and bottom negative. When it's negative, you just make the top one negative, right? Just get in the habit of making the top one negative. So when you have a -4 thirds, you've got a negative rise. Think of that as a negative goes with the 4. So your rise is a negative. You're still going to run to the right 3. Does that make sense? You with me? The negative just goes upstairs. So it means if it's negative, you go down. So it's instead of rise over run, it's fall over run, right? It's so sad. And so so what do I do first? 2! Easy peasy, right? Now what do I do second? -4. So I'm going to fall. 1, 2, 3, 4, and I'm going to run 3. 1, 2, 3, and I'm going to put a dot. And I'm going to draw a line, and I'm done. And
Wait.
I
What? Wait, go, do the down.
Okay, it says I'm going to fall -4, a negative rise. So I'm falling 1, 2, 3, 4. Did I do that wrong? 1, 2, 3, 4. And then I run 3. I'm still always going to run to the right. I always run to the right. 1, 2, 3, put a dot. Draw my line, I'm done. Easy.
So do you only need 2?
Right? Yeah, you really only need 2. But it's helpful to understand because that you can do it many times. You know, I could go down 1, 2, 3, 4, 1, 2, 3, right? It would work if I drew the line straight and if I had a real graph, right? It just doesn't work make these really fast, sloppy graphs, right? But and then 1, 2, 3, 4, 1, 2, 3, right? It keeps working. So that is helpful sometimes as we move into solving systems of equations by graphing, which is two things and figuring out where they cross. It's helpful to do the rise over run, rise over run, rise over run several times and hope that you get the same point, right? But we're not there yet. All right, so that's basically it. Fist to 5. Does that make sense to you guys? Awesome. Awesome. Okay, so what I want to do is I want to pass out whiteboards. And we're actually going to try and see how well you guys know this stuff, okay? Okay, let's practice.